All right, good morning, everyone. Welcome to my talk. Today's talk, I'm focusing on Redis Enterprise and what we are doing in the cloud-native platform space. So the agenda for today's talk is essentially around, let me start off with an introduction for cloud-native platforms. Then I will sort of step into the introduction around Redis Enterprise. And then finally, do a quick demo of Redis running on Kubernetes. And then I'll finally open it up for questions and answers. So let me just quickly start off with, what is cloud-native platform? What is PaaS? What is IaaS? So let me just kind of walk you guys through what the three basic models are. It's very basic information, but let me just set up the background so that everybody's aware what I'm talking about. So IaaS is typically infrastructure as layer. This is where you will have your hardware, networking, and all the basic compute resources for your data center or for your VPC. Platform as a service, again, it's moving up the stack a little bit where you don't have to concern yourselves with the IaaS infrastructure. We are making an assumption that the IaaS resources are available to your application. And then finally, we have software as a service. This is essentially where developers will focus on writing code, and all the platform APIs and the infrastructure is provided to you, and you don't have to worry about it and just focus on developing your application. So why PaaS in a cloud-native way? So one of the main advantages of having a platform as a service is it provides you with the basic level of abstraction, right? So you want to focus as an application developer on just writing your application code. You don't want to concern yourself about how you should run that application, where you should run it, what kind of server infrastructure you need, what kind of networking you need. All those concerns are dealt with the PaaS itself. The platform provides all those resources to you. And as a platform developer, you want to focus on writing your application. So that's why we want to focus on platform as a service and then run it in a cloud-native manner. So with the introduction of 12-factor apps and microservices, I think that's leading to adoption of some of these platforms. So I will today focus on a few of these platforms and highlight some of those that we at Redis Enterprise are working on. And the one reason that the platforms are taking off is the final sort of statement I want to make here is containers are essentially becoming the basic unit of deployment. 10 years ago, we went to a virtualized shift from bare metal. And now I think today we are sort of making that shift again from a virtualized VM to a containerized workload. So if you containerize your app, you containerize your workload, the platform then will take care of running your workload in the most efficient manner. So that's a little bit about what is a cloud-native platform and why you would want to use the platform as a service. So let's talk about the next step in the platform is orchestration. Why would you need an orchestrator to run your containerized workloads? Well, if you think about a microservice, right, you are taking a monolithic app and you're breaking it down, decomposing it into smaller microservices. And let's talk about you are containerizing each of those microservices. So how are you going to go orchestrate that scenario? So you're looking at dozens of services where you will have to schedule it in production environment. You're more than welcome to do it yourself without an orchestrator, right? But I think that's a monumental ask. So one of the key advantages of picking a platform is it allows you to not only run your applications in a containerized format, but it also helps you orchestrate it, schedule it without you having to do it yourself. So if you're thinking about high availability, if you're thinking about failovers, platforms help you do that because they have their own schedulers, and the schedulers will take care of the basic restarting of your app, restarting of your container. So that's the advantages of using an orchestrator that comes with a platform. Today I will focus on a couple of these platforms. The first one I want to focus on is Cloud Foundry. It's an open source project. It's sort of led by Pivotal, but it has over 50 organizations contributing code to it. The idea behind Cloud Foundry is that it will help you build and run your container at the same in the platform itself in a cloud native way. And I think it's very important to highlight that distinction if you guys are not aware of Cloud Foundry, because the second one that I'm going to talk about is Kubernetes. How many of you guys have heard of Kubernetes? How many guys are using Kubernetes in production? Keep your hands up. I got one hand, two hands still up. Okay, great. So everybody's kind of on this journey of adopting Kubernetes or trying out Kubernetes. But I think that's one of the key differences between these two platforms. In Kubernetes, the concern of building the containerized app is basically on developers, right? You have to pick the runtime for your container, whether it's Python, Ruby, Node.js. You have to package it up yourself, and then Kubernetes will take care of orchestrating and scheduling your workload. On the other hand, Cloud Foundry, it's responsible for auto-detecting what runtime your container needs, and they will lay down the container runtime for you and then schedule that container for you. So that it has a little bit of a distinct advantage when it comes to containerizing your workload. So I will go a little bit more deeper into each of these platforms and platform orchestrator. So let's talk about Cloud Foundry itself. So like I said, Cloud Foundry is an open source project. It is mostly meant for 12-factor apps. It's designed for your stateless applications. So when you are writing your application, the only thing you need to focus on is essentially doing a Cloud Foundry CLI command, CF push, because then Cloud Foundry itself will lay down the application runtime, which is essentially using build packs in the Cloud Foundry ecosystem. Then it has its own scheduler. The scheduler is called Diego. So the Diego will essentially schedule your containerized application onto a particular node or a VM. Then it also has these other basic constructs for routing of application traffic. Inside the platform, it has a centralized logging system called Loggregator. And then all this is orchestrated using its own orchestration tool called Bosch. So Bosch is open source, so is container runtime and application runtime. This platform uses Open Service Broker API. So you can write your applications and expose your services into this platform using the Open Service Broker construct that is being adopted by all the other platforms as well. So it's kind of becoming the standard way of deploying your service into this platform. Now, some of the use cases for this Cloud Foundry platform is essentially when you're trying to build your microservice. So one of the things that you want to focus on is, as a developer, you essentially want to write your code and do a CF push. And the rest of the concerns of scheduling, building, is all handled by the Cloud Foundry platform itself. One of the other things to highlight here in this Cloud Foundry, it's a recent, like less than 6 months development, is Cloud Foundry has decided to adopt the Run C library. Now, if you guys are familiar with Docker, Docker also uses the runc library. So the advantage of using the Cloud Foundry is essentially it's 100% binary compatible with your Docker containers. So if you already have Dockerized it, Cloud Foundry will help you run your containerized app onto their platform. And again, one of the things to highlight is this is essentially meant for a 12-factor app, which means that you're running your stateless application inside of Cloud Foundry. The second platform that I want to sort of highlight is Kubernetes. Pretty much everybody in this room raised their hands around what is Kubernetes, so I don't need to go into too much of an explanation. I think there was a great explanation done in the keynote as well this morning. But let me just quickly highlight some of the advantages of Kubernetes itself. So it's an open source project. A lot of organizations are starting to contribute to it, started by Google, obviously. So it provides basic health checks for your Dockerized workloads. One of the key differentiators between Kubernetes and the Cloud Foundry is it does stateful as well as stateless workloads. So if you are looking at which platform to look at for your adoption, you should consider what kind of workload you want to run, what kind of platform you want to run based on whether your application is stateful or stateless. So it has a couple other sort of constructs or primitives that you can take advantage of. It has this ability to provide service discovery. So if you write your own service, it has a service catalog where you can publish your service and you can have them, the rest of the cluster users use your service if you write your own service and service controller. So one of the good use cases for Kubernetes, like I talked about, is around flexibility and customization of your application or your service. So I think Kubernetes makes sense if you have to migrate your workload, whether it's stateful or stateless. I think both of those use cases can be accomplished in Kubernetes, right? So that's a very quick introduction. That's a more than 10,000-foot overview of what Kubernetes is. There are a lot of details that I can go into about Kubernetes itself. That could be a whole track in itself. But I just wanted to give a quick overview of what Kubernetes is before I sort of move into what we are doing as Redis Labs in both of these platforms. Which brings me to let's talk about what is Redis Enterprise. So I don't know if you guys know, we are the home for Redis. So the Redis OSS is Salvatore, works for Redis Labs. Redis Labs itself has its own product. It's Redis Enterprise. Redis Enterprise has Redis OSS at its core. We add some additional functionality to make it more performant, reliant for enterprises, and makes it easy for developers to adopt. So let me kind of step into a little bit more details of what are the advantages of Redis Enterprise. So we essentially provide an easy mechanism to do HA and DR capability over Redis OSS. I think in the keynote, Iftak mentioned we are doing CRDTs as a way to replicate across geos. We also provide ability to do built-in searches and other sort of capabilities. We are making it extensible. So with the introduction of modules, we can have various use cases that we can satisfy with Redis Enterprise. But I think the biggest sort of takeaway here would be is like we offer high availability, reduction in total cost of ownership, and we definitely offer performance of Redis by letting you utilize all the cores that are available to your infrastructure. So let me dive a little bit deeper into the architecture of Redis Enterprise. So I think Uri touched on it a little bit in the keynote, but let me emphasize this again. we run a symmetric architecture for our Redis nodes. What does that mean? Essentially means that we run an identical set of software on every single node. So we don't have a very distinct capability of whether or not a node is a master or slave. We have the same bits running on every single node. So it's very easy to handle failovers, and it's very easy to look at how we can scale because we don't have to specify any particular role or a particular way of configuring our nodes. They're identical in functionality. It helps you go scale your Redis application in a very seamless manner because the nodes are identical. We also provide an additional layer of basically a zero latency proxy, which helps you distinguish the capabilities that we're bringing to the Redis community. So what I mean here is we have a specific zero latency proxy that helps you do the control plane. And then you have an additional layer, which is the data plane or the data path. And that is essentially the Redis shards that you guys are all familiar with. So our proxy takes care of the cluster management and takes care of the control plane for you and lets you focus on sort of populating your database using the data path sort of identified here at the bottom layer, which is your data shards that you're most familiar with. So let me talk about why Redis Enterprise on Cloud Foundry, right? So I kind of sort of set up the stage on introducing Cloud Foundry to you. Now let me talk about how they belong together and what we offer to the developers using this combination. So our cluster itself does multi-sharded, multi-tenancy inside the cluster itself. So when we talk about Redis Enterprise, we are talking about multi-tenancy. So we have the ability to have multiple databases inside the single cluster. So as a developer, you don't need to spin up your own cluster. There will be a single cluster inside your business unit or inside of your organization, but that cluster can have multiple databases inside of it. It is set up in a multi-tenant fashion, so we provide isolation between the databases so that each developer has access to their own database with low risk of any sort of cross communication. Obviously, if we are going to be in Cloud Foundry, we want to take advantage of the orchestration layer that is provided by the platform. So we have Bosch integrated tile or Bosch integrated software that we leverage in a Cloud Foundry ecosystem. So what that means is we have our own orchestrator, but we are also leveraging the platform's orchestration layer to deliver the service to the developers. One of the key advantages here in our Cloud Foundry ecosystem is we have introduced CRDTs. CRDTs are, again, it helps you with multi-foundation database replication. So let me break that sentence down a little bit more. If you notice the diagram, I think I have identified essentially two boxes. They are similar. So this is essentially running two Cloud Foundry platforms in two different geographies or in two different data centers. Redis Enterprise using CRDTs and Cloud Foundry TCP routing allows you to have a CRDT database across two data centers or two geographies, right? So you can have multiple writes. If you have applications that want to take advantage of that, and using the CRDT algorithms and constructs, we can help you sort of leverage the capability in Cloud Foundry platforms itself. Normally, Cloud Foundry platforms are typically deployed in the same data center, but with CRDTs, you can span across these Cloud Foundry foundations and take advantage of the geo-replication capability. The deployment model I want to highlight here is Cloud Foundry is open source, but we are leveraging the Pivotal's distribution of Cloud Foundry called Pivotal Cloud Foundry. So Pivotal has its own sort of packaging format that is slightly different than a BOSH release. So we have two products in the Pivotal Cloud Foundry ecosystem. One is a completely PCF BOSH integrated release that we call Tile in the PCF ecosystem. And the second one is also around a service broker. So we are taking advantage of the PCF service broker as well. So what are we doing in the Kubernetes space? So let me just talk about what we are trying to do in the Kubernetes ecosystem. Obviously, we are building it for the container era. We are building it from ground up. So one of the sort of things we heard from the Redis community was if you want to create a cluster, it is a little bit of a manual process. You might have chef recipes or you might have some playbooks, but it's not a easy thing to set up. So in the container space, you're typically going to have a little bit more ephemeral workloads because pods will get spun up and will get spun down. I think in the keynote, they mentioned Google is spinning up like 4 billion containers. So they're not going to persist or they're not going to stay there for too long. So like, how do we make sure that the customers and the users of Redis don't feel that pain point? So what we have done in our Kubernetes release is we have done auto bootstrapping of the Redis cluster so that you don't have to worry about it. It will help you efficiently scale your Redis cluster. And then we are taking advantages of the primitives offered up by Kubernetes. So we are using stateful sets. We are taking advantage of Kubernetes secrets. And essentially, we have written our own Redis controller. And in the demo, I will sort of point out the advantages of using the controller that we have developed in Kubernetes itself. So just to quickly touch on the architecture and the diagram you guys see in front of you, this is essentially depicting a 3-node Redis cluster deployment in Kubernetes using a headless service that is native to a Kubernetes ecosystem. So I will go a little bit more into detail in my demo, but I just wanted to show you the architectural diagram of what we are thinking from the Redis Enterprise perspective. So we have chosen a particular path for Kubernetes. And this slide is essentially, we are trying to make an attempt on why we are picking a Redis Enterprise controller and why we made that decision. In the keynote, my colleague Uri mentioned that we want to take advantage of the orchestration framework offered up by the platform, but we also have our own orchestration. So let's talk about that, and I think this will help you understand why we picked a particular approach in the Kubernetes ecosystem. So, like the slide says, we have a cluster of clusters, right? So we have the outside cluster, which is Kubernetes, and then we have an inside cluster, which is Redis Enterprise. So let's talk about the outside cluster, which is the Kubernetes cluster. So what we are sort of giving to the platform or delegating to the platform and making it a platform's concern is we are ensuring that the platform will provide us with the nodes and the pods that Redis Enterprise needs. We are then leveraging the custom controller that we have written and then letting the platform spin up the service for us. So we are writing our own scheduler, but we are letting the scheduling of the pods to happen using the Kubernetes native scheduler. Obviously, Kubernetes provides some auto-healing capabilities, so we want to let Kubernetes deal with the recovery of those pods. Let's talk about what Redis Enterprise is going to focus on in their cluster. So in the diagram, I've kind of identified like the 5 main components of the Redis cluster itself. Some of the main components are CNM, which is our cluster node manager. So like the name suggests, this one is responsible for managing the Redis cluster, making sure that the master and slave are talking to the cluster and we know who the master is. That's all CNM's responsibility. DMC proxy is our smart proxy. That helps extend Redis functionality by managing the sharding and the clustering capability of the Redis Enterprise cluster itself. Then we have a couple watchdogs that are watching over the processes so that if there is a failover that needs to happen between a master and slave shards, that can happen automatically, and it will be transparent to the Redis user itself. And finally, we have some state that we store about the cluster in CCS, which is our cluster configuration store. So that if we have to, in case of a disaster recovery situation, we can use this CCS configuration data and we can help you recover the entire Redis Enterprise cluster using the metadata that is generated and stored by the CCS engine. So why did we go with this strategy of double orchestration? So one thing, just to kind of set up history and context, we had our own orchestration before sort of Kubernetes started gaining momentum. So we have been using our own internal orchestrator for over a year and a half. So now the question became, like, at what level should we integrate our orchestrator with the platform orchestrator? So, I think I have to say our R&D has done an extremely good job of creating the right level of integrations with our orchestration layer and sort of delegating the right primitives to be orchestrated by the platform. So I think that's why we want to focus on, let Kubernetes do what Kubernetes is good at, which is scheduling of pods and leveraging primitives like stateful sets. But we want Redis Enterprise and its orchestrator to do what it's good at. And Redis Enterprise orchestrators are good at sort of managing the sharding, the shard placement, the key placement, and sort of taking care of how you want to do placement of shards in a multi-node Redis cluster. So DMC proxy is very fast and transparent, and it's really efficient at allocating those resources. So we want to take advantage of that capability and not let the platform scheduler worry about the life cycle of the data that exists in Redis. Essentially, in our double orchestration scheme, we have a single product, but we have 3 deployment models. One is we have a fully managed solution for you, which is in cloud. So you can just take your credit card, swipe it, get a database in return, and just continue developing your Redis application. Now, once you sort of get that notion going, and if you want to move your data and Redis databases on-prem, either on VPC or on-prem, we have 2 options for you. One is we can manage the Redis Enterprise cluster for you inside your VPC. You just have to give us some IAM roles, and we will take care of managing the Redis cluster, which is managed by the Redis experts on our team. And the final model is the traditional software model, where it's available for download for you guys to try. And you're welcome to install it on bare metal or in your own cloud yourself. And we help you sort of give you a regular cadence and a regular drop of Redis Enterprise. We try to pull in most of the enhancements that are made in the Redis open source community, and we try to quickly integrate the upstream that Salvatore releases, and we try to get that incorporated into our core enterprise product. So I think that's a lot of talk. So let me kind of switch to the quick demo of what I just described. So what I'm hoping to demo today is essentially our Redis Enterprise running in Kubernetes. And I will try to then showcase how some of those components look like in the Kubernetes land, so you guys understand what our deployment looks like, what are the different components look like, and what are the key capabilities of our Redis Enterprise release for the Kubernetes ecosystem. So let me quickly switch tabs here, go to my terminal. So since a lot of you guys are familiar with Kubernetes itself, I think what you guys are seeing in front of you is a basic deployment of Redis Enterprise in Kubernetes. So I'm just going to quickly go down the list of what I'm displaying in front of you are all the pods, services, deployments, and stateful sets that make up Redis Enterprise. So let me start with bottom up. Just to save time, I've already deployed the Redis Enterprise in a Kubernetes cluster. So I deployed a 3-node cluster of Redis Enterprise. It came up with stateful sets. It has 3 pods in the cluster. And we have our own controller, like I described earlier. We also have our own headless service that other applications can talk to. And then what you are seeing at the second to top line is a database that is getting published in the Kubernetes service catalog. So the advantage here for the developers is once you create a Redis database, it will automatically get published in the Kubernetes service catalog. So I think this is what it looks like in a deployed Kubernetes cluster. We do have a web interface for the same product. So let me bring that up. So this is what our Redis Enterprise web interface looks like. The key advantage, I think, here to highlight is we essentially deploy the same bits in any deployment model that you pick. So if you use on-prem deployment or you use Kubernetes deployment, you will see the same exact web interface. So you can sort of construct your workflows around Redis Enterprise the same way. Nothing will have to change if you pick on-prem software or Kubernetes deployment. Your workflow will essentially be the same. So what I'm showing you here is I have already pre-configured a database, but creating a database using a web UI is pretty simple. So let me walk you through how it gets created. So I'm going to go ahead and create a new Redis database called demo. Let's give it about a 1 gig of database, 1 gig of data. We're going to enable replication. And if I go through advanced options, there's about 20 other options that you can pick based on your needs. But let me go ahead and create the demo database so that you can quickly see what happens in the background, right? So again, all this is running on Kubernetes cluster. So what you are seeing on the database is on the web interface, you just notice that I have created a demo database. It got its own endpoint. It's running on port 14974. So if I run the same command on Kubernetes, what you should see is output that will have the new database that was created, and it will automatically get published in the Kubernetes service catalog. So as you see, the first line, the database endpoint has been published in the service catalog of Kubernetes. So that's the advantage of having a custom controller is You can use our REST API. You can use our web UI to create the database. But if you're a developer, you don't have to leave the kubectl CLI interface. You can discover where your database is and quickly start binding your applications to this Redis instance using this cluster IP and the port that has been identified in the service catalog. So that's a very quick demo of Redis Enterprise on Kubernetes. But wait, there's more. So if I take a look at my next sort of demo, is we are also trying to do the same thing in OpenShift. So OpenShift is an offering from Red Hat. It is based on Kubernetes as well. So we are trying to introduce Redis Enterprise in OpenShift environment as well. So what you are seeing in front of you here is an OpenShift interface. We have deployed Redis in there. So if you look at the sort of things from the CLI, you will notice that you will start seeing similarities on the output. So we have a Kubernetes controller, which I mentioned we have developed. We have a Kubernetes cluster. So if I expand that, you will see that we have 3 nodes running here as well in OpenShift. So the deployment, whether you use a vanilla Kubernetes or whether you use a hosted managed one from Google GKE, you will see a similar output. We will have a controller, you will have a cluster that you can monitor, and then you can have a database. If you create it, it will show up in the service catalog. So let me kind of show you the same output that you will see on OpenShift. So let me quickly log in to the OpenShift interface. In OpenShift, I think it is a very strict control around projects and namespaces. There's one-to-one correlation between a namespace and a project. So once I switch my project to Redis, and I run the same sort of command, I think the output will look familiar to you guys, because essentially the deployment model will reflect that we have a 3-node cluster running in OpenShift. We have a stateful set, so this is defined here. We have a Redis UI that we are exposing again, the same way whether you're running it on vanilla Kubernetes or GKE or on-prem, your web interface will get exposed and it will have a public IP. And finally, you will see the controller as well. Some of this additional stuff that you are seeing on the terminal window, we will sort of highlight here in a bit as what we are working on next. So I will leave the explanation for now and quickly go back to my final demo item. And then I will talk about the next steps. So just to quickly summarize, what we talked about is I showed you what the pods look like, what the deployment looks like for Redis Enterprise in Kubernetes. I showed you the database creation and how it gets published in the service catalog. One final thing I want to show you was this is another distribution of Kubernetes by Pivotal called Pivotal Container Service. And I don't have a live demo, but I've taken a screenshot. But essentially, what you will notice here, it's an identical output, or looks very similar to the earlier outputs. We have a 3-node Redis cluster running. The good thing about this is our Pivotal partners were super helpful to us. They gave us a PKS cluster on which I was able to deploy this release. And it's managed by Bosch. So if you look at these VM nodes here, what you're seeing is UUID. And that's an indication that it is being managed by Bosch, which is the orchestrator for Cloud Foundry. So again, props to Pivotal for giving us a PKS cluster at such short notice. and the ISV team for making this happen. But essentially, what I'm kind of demoing today is I was able to show you Redis Enterprise running on 2 different clouds. The first one, I used Google. On the second, OpenShift, I used AWS. I used 3 different distributions. One was GKE based. Another one was based on OpenShift by Red Hat. And the third one was PKS. So that's the idea, and that's the theme of this conference as well, is we want to be everywhere. We want to be in every ecosystem. So that's the release and the cadence that we are working on, is we want to be in these clouds and in these ecosystems. And we are hoping to have a Helm chart support in the near future. So I think Helm, which is a packaging format for the Kubernetes ecosystem, seems to be winning out as compared to some of the other packaging formats. So in fairly soon, we hope to announce Helm support for our Redis release so that you guys can do a one-click deploy of the Redis Enterprise in your Kubernetes cluster. So thanks again for attending. I know I'm holding you guys up between me and lunch, but I do want to open up the floor for some questions. So at this time, I will sort of take any questions the audience may have. And so I have some resources available. The slides will be available as well. So I will open it up for any questions at this time.
I have a question.
Yes.
Yeah. So the question is about the components for Redis Enterprise Cluster you described in one of the slides. So how, are they complete, how do you expose those? Are they pods running on the Kubernetes cluster, or what are those?
Yeah, exactly, right? So I think you're on the right track. We are trying to have one node per pod.
Okay.
So a Redis Enterprise node will be running in one single pod, and that's it. So that there's a one-to-one correlation. We don't want to overload that pod with other containers, but the pod itself is a container. Sure. Does that answer your question?
Yeah, it does. And one more question. Have you tried deploying more applications with the Redis pods side by side, like say any application which connects to this database?
Well, so we want to make sure that there's no noisy neighbor and other sort of problems where you try to do a co-location of applications right next to the database, right? So what we want to do is ensure integrity of the Redis cluster first, and then we use some primitives like service discovery to then connect to the service itself rather than the individual pod, right? Because I think the Kubernetes construct of services helps you avoid sort of keeping the mapping track, we offload that concern to the Kubernetes service itself.
Sure. Okay. Yeah, thank you.
Good question. All right.
So is the Redis Orchestrator aware of the CPU and memory limits on the pods from a Kubernetes perspective?
Yeah, so I think in our YAML, we sort of help describe the limits and the constraints for each of those pods. Okay. So it is tunable by the customer. Once you see it, it will be fairly obvious and apparent what those limits are. All right, folks. Oh, one more question, sorry.
So can we scale the pods via Kubernetes dashboard on this cluster, what we create, or is
Absolutely.
it possible? Right. So Kubernetes dashboard is accessible like regular on any other Kubernetes cluster?
It depends on your Kubernetes, right? So
sure.
GKE cluster, there are a couple additional steps you have to do to get access to the Kubernetes UI.
Yeah.
If you're running vanilla Kubernetes, you know how to access the dashboard. But yeah, absolutely. Our Redis Enterprise is scalable, and you can do it using either the web UI or kubectl commands, and you just say scale stateful sets to whatever number you want.
Yeah, okay. Thank you.
In the front.
So you're using multiple DBs on the same cluster to provide data level tenant isolation. How do you deal with traffic level tenant isolation? As in, one of the client can exhaust all the bandwidth, and others can suffer.
Well, so we do provide multi-tenancy inside of the cluster. So we do guarantee segregation of limits between databases. And as far as like network bandwidth goes, right, I think we offload that concern a little bit to the platform itself. So we make sure that the platform is able to route the traffic with low latencies and is able to sort of ensure that it is getting routed to the right place, right? In OpenShift, for example, we break it down by namespaces, and there's a strict sort of separation between each of the projects. So if you're concerned about some of those networking situations where you don't want the databases or the applications to have access to different databases, one of the strategies could be to like deploy things in its own namespace and control access to that namespace using the OpenShift primitives, or develop your own role-based access controls, if that makes sense. Great. All right, I think lunch is calling. Thanks, everyone.